He is well versed as a data scientist and analyst, and essentially he's got a passion for diligence, which kind of led him into getting into data and to learning Python, SQL, HTML, CSS, loads of various languages, which has kind of led him into delving deeper into data science and into visualization. But this all kind of stems from his background in mathematics. So essentially, you're in very, very, very good hands. The course is over 12 weeks, and this week's going to be looking at obviously Python. Then next week kind of gets into Panda, etc. But essentially, you're in great hands. Abdul's a well-versed, experienced lecturer that will kind of guide you seamlessly through this process. So I'm going to hand you over to Abdul. Abdul, how are you today?
Yeah, I'm good. Good morning, everyone.
Morning.
I hope everybody can hear me clear and loud.
Yes, I can hear you.
Yeah, I'm happy to be
Morning,
here.
hearing you loud and clear.
Okay. I'm happy to be here. So today, by the design, we are going to be going through introduction to Python. The aim of this lecture is at the end, we are all going to become data analyst, data scientist. So that is our goal. But there is no way we can jump the protocol. We have to understand the basics of Python. I just want to know if we have previous knowledge of coding in any language at all. I want to know, maybe we can just indicate if we have any coding experience in the past.
Yeah, I've got a SQL.
Hello?
Yeah, I've got a SQL knowledge, SQL language.
SQL knowledge, okay, that is good.
Yeah.
Anybody else?
A little bit of Python.
Yeah, I've got Python. SQL too.
Yeah,
Maybe maybe in the chats we can just put yes, I have an experience. Yes, I have an experience, so that how we know the level of people I'm dealing with, where to start from, on how fast I could be, because it depends on the experience that determine how fast we're gonna be in this first 10 week. Okay. Okay, that's good.
Maybe you can put your hand up. If you haven't got any experience, put your hand up, or
Yeah. SQL, R, Python.
Abdul, your camera needs to come up. You can hardly see your face.
Oh.
You bring your
Yeah.
Is
it good?
Keep an eye on that, buddy. Keep an eye on that.
Yeah. Yeah. So we have lots of experience there. That is good. Wow. No problem. If you don't have experience, no problem. It's still a good one. Good. So altogether, I can say we have about 85% of experience here. So it's going to make our work very fast and cool. So now let's just quickly talk about Python in general. Python is a programming language. Or are we still waiting for some other people to join the lecture?
No, not really. We can begin.
Okay.
They'll just follow us as we carry on, and the session is being recorded, so
okay.
we'll share the recordings.
Okay. Python is a programming language like every other programming, and recently Python becomes a very popular programming language because of its application in data science. So it has a very rich library that is used for data analytics and data science and machine learning. and etc. That is why Python became a very good tool for data scientists. Now, we are going to start from the basics because I want to assume that everyone, we are starting from the scratch. That's what I want to assume. And going with our syllabus, the first thing we're going to look into we'll be looking into the installation, because there is no way we can be coding without installing the necessary platform. The aim of this class is to code along and have a practical experience together. It's different from every other tutorial stuff and every other coaching where you just watch videos and that's all. In this one, we are going to code along together. We make the mistakes together. So once we are coding, you tell us what's your experience at your own end, and we'll make mistakes, we correct ourselves. That is how we are going to deal with this class. We'll be dealing with this class. So the first thing we are going to do, we are going to install the platform where we are going to be comfortable writing our codes. And there are so many platforms that we can use. For example, we can use VS Code, which is going to be the one we're going to adopt for this program. We can also use Google Colab. So everyone, that one is going to be easier. And then at the same time, it's possible we can use Spiders and many other platforms, but what we're going to adopt for this program is going to be Visual Studio Code, VS Code. So I want to know, do we have VS Code on our system?
Yeah.
Please say yes, 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 yes. And then if you don't have, quickly install the VS Code, because we're going to be coding along together. VS Code. Please, do you have VS Code?
Abdul, please, can you drop the link to the platform into the chat, and then I'll quickly download it onto my PC?
Okay, I will.
Thanks.
Is it Windows or VS Code?
Yeah, that's right. Android, Windows, yeah.
Oh,
yeah.
Okay. You get your link now.
Currently using a Mac. I'm not sure if I have it.
So you get the link?
Is it in the group chats or?
Yeah, let me check again.
I can't see it.
Okay, you will get it now. I'm trying to get. Okay. Now?
Okay. Oh, right, yeah.
Yeah, kindly download and install appropriately. Download and install. Meanwhile, before we download that, we can leave that for now and just quickly go through Google Colab. We'll be using Google Colab so as not to waste our time. When after the program, you can go and install the VS Code so that next time you can use VS Code. So let's quickly go to Google Colab. Please go to Google Colab.
Hi, Abdul. So for Google Colab, do we just need to go to our browsers and
that is what I want to do now. Just go to the browser.
Okay. I think you've got access to sharing your screen if you want
That's
to.
what I want to do.
Yeah.
So here on my screen, I hope everyone can see that. Just type Google Colab. You see that?
Yes, seeing.
Okay. Then go to Notebook. You see Notebook? On your Google Colabs, you can see Notebook, right?
Yes, seeing notebook.
Okay. So you can click on New Notebook. So once you click on New Notebook, it will bring you to something like this. You see that?
Yes, I'm seeing that.
Okay, that's good. So let's start from Google Colabs instead of using the VS Code. Because in VS Code, we have to install, but Google Colabs, we don't need any installation. Are we all there? Please, if you are there, let me know. Let's just chat and say yes, 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 we are there so that we can all start together. So we should be on this page. Google Colabs, Neon, Notebook.
Yeah, sorry, Abdul, I'm not quite there yet. I've only just managed to download and install. Is it Visual Studio?
What I'm saying is that we can still leave the Visual Studio for now. You do that after the lecture.
Oh, I see.
And use them or the alternative, the Google
Got it.
So we don't need to download or install that one.
Got
Just
it.
into your browser.
Google Colab. Got it.
Yeah.
Okay.
Yeah. So when you get, let me go back again. Go to your browser like this.
Yeah, got it. I'm on the home page now. That's good. Thanks.
Okay. I want to reshare so that everyone can join along. This is one of the major difficult things to do. Starting, once we start, then everything is going to be smooth. But we just have to get it right. Start together. Here. Hello, are we out there?
Yeah.
Yeah. Okay. So you come to your browser and you type Google Colabs. So when typing Google Colabs, you go to Notebook. So I want to start a new notebook. So everyone should be here now, right? I hope we can all see my screen. You can see the screen.
Yes, seeing the screen.
Okay. So this is where we are going to be typing all our code for now. So after the lecture, we all can go and download the VS Code because I would prefer we use the VS Code, but not to waste our time. We should start using Google Colabs for today. And the first thing we're gonna do according to what we have on our syllabus, is to introduce ourselves to the fundamental of Python. When you get here, we have to write some code in this. In our Google Colab, we have what we call shell. This way I am typing some stuff is what is called shell. This is where we are going to be typing everything we want to start type. We can add more shell by clicking this code. If I click, you can see more is added, right? Right?
Yep.
Yes,
Right,
good. We
right.
see that.
Yeah.
Yep.
So you can see that we have more of this shell here. So we are going to be typing in the shell. Everything we want to do is going to be in the shell. For example, if I decided to say 5 plus 2, I've typed that, I can run. This is what you are going to press to run it. So it's running. And this says it's 7, right? So if I like, I can say 1,000 minus 50. I run it, and you see the output. So on this shell, that is where we are going to be writing all our inputs, and the output will automatically be generated. Starting with Python, what we are to start with is we want to start with the basic data types in Python. Data type in Python. So this is what we are starting with, data types in Python. So we have what we call data types. We have different data types in Python, and these data types, they are integers. We have integers data type, int. We have bool. We have string. Just a string. And we have some other data types like list, dictionary, and etc. What do we mean by all these data types? When you talked about the integer data types, this is where we are starting from. The integer simply means numerical data. Numerical data. For example, I want to write anything that is number. The data type I'm using for that is called integer. But one thing with Python is that Python will automatically get the data types of any data you put in, you try to write in it. For example, if I just come and say A is equals to 15, this 15 is an integer data type. I don't need to tell Python that this integer, this data type is an integer, because Python will automatically know that A is an integer. Please, are you with me?
Yep.
Now, if I come here and say B is equals to hello world. This is another data type that is string. Anytime we're talking about string, we are talking about something like an alphabetical data type. So at the same time, I can come here and say C is equals to true. This is another data type that we call bool. That is Boolean. And if I come here and say D is equals to, let me just give a data type like come, go. Okay, do, go. So this is another data type. And then I can come and say E again is equals to 15. Mango. True. Yeah. This is another data type. All we are saying is everything you say as a data here, they have gotten the kind of annotation like you are a number, you are an alphabet, or you are a word, or you are true or false. Those are what we refer to as the data type. The A I wrote as 15, I said that is an integer. Integer is a whole number. I could have another one that is not an integer, that could be 15.5. Is another 15.15 is another data type. That is a float data type. So it means a number can be of the type float and can also be of the type string. And of the type integer rather, a whole number or of a decimal place. So when we are talking about word, we can put a word and assign it to anything and we call it a string. Like we assign B, hello world to B, we call it a string. We can assign a true to something and we call it true, or we can call it false. We say that is a data type which we call Boolean. A Boolean is only true or false. And we have some other data types like we call them list, the one I call D. It is a list of data, come, do, go. We also have another list, a list of data, and we call it E, 15, mango, and true. This is true about all these data types. That's number one. A numerical data type. Numerical data type can be of the type whole number or of the type what? Float, decimal place. Of the type decimal. If it is a whole number, we call it integer. Integer is the whole number. And we have decimal place, float, is of the type decimal place. From this little expression, we can classify this data we have up here to either a float or we can identify the one that is a float and we can identify the one that is what? A whole number, integer. So let's start by saying we want to assign them to a value. A value we call variable. What is the variable? Please, almost everybody, I want everybody to talk, to speak, so that we can be, and this can be an interactive class, please. Almost everyone. Hello?
Hello.
Yeah, please unmute everybody so that it can be an interactive class. I don't just want to be talking, be the only one speaking.
Yeah, I think everyone has access to unmute themselves and talk if they want to. So
Okay, please,
Yeah.
everybody, this is an interactive class. So I want everyone to talk, to speak, as we are talking together so that it's not just going to be one way. The reason why it's like this is because we want to make this an interactive class. And as I'm typing anything, ask questions, let's talk together, let's discuss to make it interactive. So I don't want this one to be like a video tutorial where just only one person is talking. Everyone should talk and we interact. Please. Are we there?
Yes, we're there.
Sure. Thanks.
Yeah. So let's go back to where we started from. We're talking about the Python data type. And in Python data type, we say, I said we have gotten different data types. And some of these data types, we say it can be of the type integer, it can be of the type Boolean, it can be of the type string, and it can also be of the type list. There are more of these data types, which I will just copy and paste. I have the note already. Please let me quickly paste some of them for us. Okay. These are the data types I want us to talk about. The numerical type is of the type integer, float, and complex. I hope we understand that. The numerical data type, they are the type of integer, float, and complex. Do we understand the grammar?
Yes. Can you explain complex, please?
Yeah. So when we talk about complex is the complex number. We may not really need that here in, but we just have to talk about it. When you talk about complex in mathematics, we have what is called complex number. Let me go. For example, if you say S is equals to 3 plus 5j plus 5j. Okay, this is a complex number. It's not just ordinary number. We call this a complex number, right? So anytime you see something like this, S is equal to 3 plus 5j. We call this type of number a complex number. The 3 is the real part of the complex number, while the 5j is the complex part. So we call it a complex number. So if I run it, it's going to say this as a complex number. And if I call the type of S, let me just say type of X, for example. So you can see that the type of S is complex. I hope you see that now.
Yeah.
What I'm trying to do is to check what type is this S. The S is the placeholder here. Is the one holding 3 plus 5j. Immediately I run it, it's telling me that this S is not just ordinary number, it's a complex number. So we are not going to be working with complex number here, but we just have to mention it. We just have to mention a complex number. So we'll be dealing with majorly with float and an integer. I hope that is clear, right?
Yeah.
So let's now change this X to something else. Let's change this to 300. 300 is going to be what? An integer, right?
Yeah.
Right.
An integer is a whole number. A 300 is an integer. So if I run this cell, I run it, it has run, and I go and run the type now. It's going to tell me is the type what? Int. I hope you see that.
Yeah.
It's telling us that this 300 is no more a complex number, is now an integer. Now, if I come again and turn this S to, instead of 300, okay, I can as well say 10. And if I run it again, it's still going to tell me that 10 is an integer, is a whole number. Even if I like, I put negative. For example, minus 10 is still a whole number. If I run it, the else is minus 10. If I run the type, it's still going to give me an integer. But now, let me now turn this S to 10.5, for example. It's no more a whole number, right? So once I run this minus 10.5, if I run the type of S, is now float. I hope you are getting the difference between complex number, float, and integer.
Yeah, sure.
Yeah. So a complex number contains a complex like a J on it, while an integer is a whole number. And then while talking about a float contains decimal place, a decimal point rather. I hope that is clear. Right?
Clear, crystal clear.
Yeah, so now I want to assume we are done with the type numerical type. We'll later be picking them one after the other and talk about the methods of what we can do on them. This is just an overview of what the data type look like. We'll be taking them one after the other. We take the type int, we take the type float, and talk about it. But let's just quickly look into all the data type first. Now, I still want to use the placeholder S to talk about a data type string. So if I have a data which I call S, and I call it black data professional network, right? This is not a number, right? Is maybe a word or maybe a sentence, an alphabet. So anything that looks like this is no more a numerical data type. It is called a text type, which is called string. So if I run this and I say my S is black data professional network, and I call on the type, it's going to tell me that this type is what? Strings, right? So I could come and say else is equals to hello world. Hello world. If I run it, I call on the type of this S, is going to tell me the type of the S is string, because this is not a number, is a word. Now, I want someone to tell me the difference between when I assign number as when I assigned a number and when I assigned a string. This is what I mean. For example, if I assigned a number like my number is equals to 35 or 36.5, and I come here and I assign another one and I say my word. For example, is equals to hello. Please, what is the difference between the two? The number and the word.
All right, so the difference is the number, you use numerical figures, while with the string, you can also use numerical figures or alphanumeric, I should say, but they are enclosed in open and closed quotations.
And what? They are enclosed.
Open.
Yeah, for me, I feel the number is a float.
Okay.
I think
the data type for number variable is a float.
Okay.
One word is a string. The data type for the variable word is a string.
Okay. But this is one thing I just want also to, the first person that spoke was talking about enclosing the word in what? In a quote. You can see me
Like
say
bracket.
You can see me say
can put-
world is equals to, I don't say world is equals to hello, like this, right?
Yeah, John.
I hope you see the difference between the two. The first word, let me say word 1 and word 2. The second word 2, is not enclosed in the string, right? It's not enclosed in a quote.
Yeah, you don't put the brackets though.
Right? So which shows that to write a data type integer string, you have to put it in the quote. The quote can be a double quote like this. Hey, or like this. Either double or single one. I will say the difference between the two. Please, are we there?
Yeah.
Yes, we're here.
In writing a string, we always enclose a string in these codes. We must always write the string in between these strings. Either we use the double or a single one. The two are valid. When I do this, anything I write within this string is going to be a string. Anything I write within those codes is going to be a string. But if I just write a number don't need to be enclosed in the code. Immediately you put the number in the code, it automatically becomes a string. It's no more going to be a number. For example, this number I wrote, if I just put the code, right? 3.5 in code, and another one, let me say number one is equals to 336.5, and number 2 is equals to 36.5. The only difference is that the first one, there is no code, then the second one, there is a code. So if I run that number 1, and at the same time I run number 2, and I come down here to ask for their type, I say type of what? Number 1. Number 1. If I ask for the type of number 1 now, it's going to tell me this type of number 1 is what? An integer, a float rather. Float, right?
Float.
Right? Now, if I still come down and ask for the type of number 2, let me just copy this and say type number 2. What did you think is going to be the output?
String.
String. And the only difference is that I only put this in the code. Anytime you put anything in a code, it automatically becomes a string. Be it a number, be it an alphabet, or whatsoever, it becomes a string. So you know when to write a string, how to write a string. A string is always in the code, either a single quote or a double quote. But a number will never be in the code. You just write the number like that. That is the difference between the string when you write a string and when you write a number. So we have talked about the type integer, the type float, and we also talked about the type string. Let's quickly talk about some of this sequence. We have what is called list. Let me come down here and say my list. Is equals to 1, 2, 3, 4, 5, 6, or anything. So you can see the difference between the string and this list I just defined is that the string is in a code, while this one is in a angle brackets. You can say I put a bracket before writing a list. A list will always be in a bracket like this. List 1. If I just say is equal to, anytime I just put this automatically become a list. Although there is nothing in it, this is an empty list because of this angle bracket. This is a list. So now, if I run this, my list, and I now try to call on the type of my list, If I run it, it's going to tell me that it's a list. Are you able to see that? Are you with me?
Yes.
So this is a list. Even this one that has nothing in it, provided I put the angle bracket, and if I run it, and I say list 1, I run the list. Let me go and ask for the type of list 1. If I run it, it's still going to tell me a list, though it's an empty list. The difference between this list and this list is that this one has some element in it, while this one has no element in it. A list can be of either everything is going to be a number, or it's going to be an integer, it's going to be a float, it's going to be a string, it's going to be the combination of any of those things. For example, I can come and say list, my list 1, I can change this to 1, and then if I like, I put a word. I can say you, and I can still come and say true. So I put every different type of data type in it. Yet it's a list. It contains a number, it contains a string, and it contains a bool. So even if I run this, it's still going to run. When I call on the type will still be a list. A list that contains an integer, it contains a string, it also contains a bool. That is what we call a list. We have not even talked about bool itself. Let's quickly look into what we call a bool, for example. If I say declaration, declare. Maybe I just want someone to declare something, and I say declare, and you just simply tell me it's true. What I'm telling you is true. So the type bool can only take 2 values, either true or false. So I can say declare is true. I can say declare 1, or maybe declare 1 or declare 2. I don't want to use capital letter. Declare 1 and declare 2. This is false. You are starting with capital letter. This is a false. So if I come and run that, let me just run this. Let me run the shell. And one thing I want you to notice is that every shell run is marked. If you didn't run it and you try to call it, it's going to flag an error. You can see when I run this, it marks it that it has been run. So I can call on any declaration if I've not run the shell. It's going to say maybe it's not declared. So I have to run it first. So since I've run this, I come and say declare 1, the type of declare 1. Let me just say type. And run. So when I run this should tell me that this is a Boolean. If I turn it to D2, D2 should also tell me that this is a Boolean. Either D1 or D2 should tell me this is a Boolean. So we have been able to introduce ourselves to some of these data types. We talked about the integer, the float, the complex, the string. We talked about the list. We have not talked about tuple. There's also what we call a tuple. It's almost the same thing as a list. The only difference is the way you declare it. let's remember how to declare our list. Let's say list. Let's say my list. My list is equals to, you can, I have to put the angle bracket. Let me put a day. A day. Let me say Joy. Let me say maybe Troy. For example. This is a list of names, maybe list of the names of students in my class, and I have Hadi, I have Joel, I have Troy. Immediately I run this. This, if I call for the type, is definitely going to tell me this is a list. But I still want to have another one. I want to call it my tuple. My tuple is equals to, now see the difference. Instead of using the angle bracket, you just use a bracket. So let me copy the same thing and put inside. So let me run this. So I've run my tuple. You can see the difference between them is the choice of the bracket. If you use the angle bracket, it becomes a list. If you use the normal bracket that we know, that becomes what? A tuple. Let me call the type on them. Type of list one. Sometimes you can just copy and paste instead of, so if I call this, it will tell me this is a list. Now, let me call type of the my tuple. So if I run it, it's going to tell me this is tuple. I hope you see the difference, right? This is a list. Why the second one is a tuple? The only difference at declaring them is just the nature of the brackets used. They all have their uses, the use cases. But for now, we just need a general understanding of all these data types. So let's look into some of the data types that are common that we can always talk about. We have a data type of range. We also have a data type called range. Maybe later we talked about that range. We are going to talk about the range. And we have a dictionary, Dix. We're also going to talk about the dictionary. We have talked about the bool, but we also have what we call sets. A set is just almost the same way as this of the list. It's just a choice of bracket as well. You know, in set in our ordinary mathematics, we declare a set using a curly bracket. A curly bracket like this. If I copy this list and I put it here, this, if I don't want it to be a tuple, I can decided to call it, if I decided to call it a set, the only thing that will change is going to be this bracket, the choice of bracket here. You can see the nature of the kind of bracket I use. So this becomes a set. All those are words we're going to look into one after the other.
Hello,
now,
Abdul.
Yeah?
Sorry. So do the brackets change automatically? So if I just type my set, will the bracket just automatically be inserted, or will I have to type it as well?
Oh, this bracket, right?
Yes.
No, one thing is once you have to type it. You have to type it. Typing it is declaring it. Okay?
Okay.
I understand what you're saying now. You have to type it. You don't just say set. The set I use is the choice of name. If I like, I may not call it my set. I may call it my name or my names. If I like, I come and say my names.
Right.
Okay. So that is what we call a variable. So the variable you use is left to you. You choose the variable name you like. So the variable name don't automatically set the data type. You are the one that will set the data type of what you are using. And one of the ways to set the data type is to use the proper bracket or
Right.
quote, quotation. I hope you get the point now.
Yeah.
Okay, that's good. Now, since we have been able to introduce ourselves to what all these things look like, the numerical data type can be of the float, can be of the integer, it can be of the string, and the text data type can be of string. We have sequence data types, which can be of the list, tuple, and range. We have not talked about the range. Range is just like set. You want to get set of numbers, say from number 1 to 10. Let me. I said I'm going to talk about it later, but since we are doing quick introduction to everything, let's quickly set some range here as well. Let me say my range. My range is equals to range 5. So okay, 0 to 5, from 0 to 5. You can see the range I brought out. I say range 5. If I go and change this to range 10, I run it, and I come back to run this. It's telling me you are getting a number from 0 to 10. So later we're going to talk about that. Is a sequence as well. So we talked about the tuple already. We talked about list already. We have not talked about dictionary. Is a lot. Is a lot talking about dictionary. The dictionary is also declared. For example, if I say my date is equal to, in a dictionary, you are going to have a key, and at the same time, you have a key, and then you also have a value. For every dictionary, there will always be a key and a value. So let me just copy a dictionary, for example, as an example, so that we just have a quick overview of how dictionary look like. Or we declare one for ourselves. Let's declare one for ourselves. And okay. If we want to assume we have a dictionary of maybe dictionary is just like we declare dictionary using this bracket as well, the curly bracket. We have declare one data type using curly bracket. Can we remember that?
Yes.
Which one? Set. Can you remember we have a set that
yeah, that's right.
A curly bracket. If I come to this curly bracket now and I say 3, 2, 5, 9, 10, if I call for the type, it's going to tell me this is a set. Let's just see. And that goes back to asking us that, telling my dictionary does not automatically declare a dictionary. So let me just say type and say my date. This is not a dictionary. I just want to point out some stuff. So you have my dictionary. Oh, type. Okay, maybe what happened? Control C. Maybe I didn't write the name very well. I have an error. Okay, what happened? Okay, you can see my dix is not divine, right? Please, who can tell me the reason why I'm having this error?
You didn't run it.
I didn't run it. You know, initially I said anything I run, it should be marked, right? So because I did not run it, there is nothing like in my dix. It can't figure out what I mean. So if I run it now, So it has been marked. Now I can call anything on it, my date. So it's now a set. It's not a dictionary, it's a set. So, and I just want to point out that dictionary and set, they use the same curly bracket. But the way we declare the element in it is different. For example, if I want to make this as a dictionary, I want to say boy, for example, the number of if I'm in a class of maybe year 7 students, and I say the number of boys in the class, they are equals to maybe 5. Number of girls in the year 7 class, in the year 7 class, maybe they are equals to like 15. This is a dictionary. In dictionary, we always have 2 values. The values, the key, and the value. The key is boy here. How many boys do we have? We have 5. Here we have the key, girls, and we have a value 15. How many girls do we have there? We have 15. So this becomes a dictionary and not a set. I hope you understand the way we declare a dictionary now. Let's declare another dictionary. Let's declare 2 dictionaries, maybe my dic 2. Is equal to, let's have different type of fruits, maybe mango. Maybe I want to go and buy mangoes, and I say the number of mangoes would be like 15, or maybe it should be 15 pounds. And then I want to buy orange, and I say maybe the amount allotted to the orange maybe like 5 pounds. Then I want to have maybe apple. Apple, and I want to say maybe that wants to be like 3 pounds, for example. Oh, 3 pounds. So this has gotten a key, mango, and has gotten the value 15. This has gotten a key, orange, and we have a value 5. This has gotten a key, apple, and we have a value 3. So in the dictionary, we always have a key and a value. Let me run this. So if I run this and I come back to run my dic, yeah, I should get a dictionary. Either 1 or 2. Let me run 2. You can see I got a dictionary, right? Hello, everyone.
Right.
I have a question though.
Okay, please go.
Can the number 5 for boys and 15 for girls, can the numeric value be changed to a Boolean?
Yes,
like
yes. For example, if I like and I decided to say true, it means in the class, in that class, if I say boy, I say true. I'm saying we have boys in that class. If I like, I say false, for example. It means when you say false, automatically there is no any girl in that class. So if I run it again, the dictionary.
Spell true correct.
Oh, true is not correct. You can see I have an error. Error is Tor is not divine. It means my true, the spelling is wrong, right? Right? So if I run it again now, there will be no error. Okay. So you can design anything you love to put in the dictionary. You have the control over all this. The only thing is, it's going to be wrong if I say boy and I did not put the quote, right? I just say boy. A boy is a string. So I have to put the quote to show that this is a string. It's not going to give me a good, it's going to give flash an error if I do not put the code. Those are the only thing we just need to look into. This is just the overview of what we mean by talking about the different data types. And this data type is very important. You must know this. You must know when to use a particular data type at a particular time as an analyst or a data scientist. For example, you have a table, and the table contains different data. For example, someone want to measure if someone is going to have a diabetics, and in the diabetics table, you have the body mass index, you have the maybe diabetics and pedigree, diabetic pedigree, like history of diabetics, like in the family, is your family having a diabetes history? Is just a true or false? You should know that that column should be Boolean. Yes, it's true. This one is false. Then you have to measure something like body mass index. The body mass index is going to be wrong if you put body mass index as an integer. It should rather be a float, because you can find a body mass index that will be something like 23.5. 30.2. So if you go and give your table and assign an integer to that type of data type, it's going to be wrong, because it should rather be a float. Those are the reasons why you have to understand these different type of data type, especially the integer, the float, and the Boolean. You have to understand it very well. So now we're going to go to the fun part of this data type. We are going to pick the data type integer and talk about integer alone. So we already understand what we mean by integer. We already know that this is a word, but before then, let's quickly run talks about variables. Yeah, variable, for example. What is variable? A variable is just a name you give. I hope you get that now. A variable is just a name. A name you give to anything, a name of anything. That is called a variable. You can see that from the beginning of this Jupyter notebook, we have been talking about different variables like else. We have been talking about, we use else, we use my list, we use list, we use my tuple, we use different things. And this what we use as a placeholder is a name. Like for this, we say my list is equals to. It means the name of this list is my list. We say my tuple. It means the name of this tuple is my tuple. So this kind of name that we assign as a placeholder is called a variable. The common variable we use in mathematics, like x and y, is a variable. It's not really encouraged here. Anytime you are programming, you don't use a variable of x and y. It's not encouraged. It's not as if it's bad, but it's not encouraged. You use a variable that's, once someone look at the variable name, you will know what that thing is talking about. You'll be able to, from the name, you'll be able to say, okay, this one to talk about something. For example, if I come and say a variable, for example, a variable name, let me give a variable name like a variable name like car, okay, cars. So if I just say cars, immediately you look into that, you already know that maybe I want to be talking about different types of brand of cars, or different type of cars, color, or whatsoever. You know, what this thing is going to hold is going to be something related to car. So if I have a variable name, maybe I can say car name. Or I can say car list, or list of car. Right? So this is a good way of giving a variable name. The placeholder, once you say the placeholder, you should be able to have some reason on what that thing is talking about. At the end, this might be a list, it might be a dictionary, it might be a tuple, it might even be a string, but you already have an idea of what that is talking about. You don't just give a variable name to, you don't just assign a variable name. You try to ensure that you follow some rules at assigning a variable name. So the rules are, let's look into the rules that governs a variable name. I mean, I have some notes, let me just copy. Are we there?
Yep.
Okay, I just want to copy. I don't want to be typing. I already have them just to copy it. Control-C. Can you see my screen? These are the rules that we must obey anytime we want to give a variable name. Variable names are containers for storing data values and are identified by a name. That is what a variable names are. So a variable names must start with a letter or an underscore. Everybody knows what an underscore is, right?
Yep.
Okay.
Yes.
This is an underscore. There's an underscore. It's not minor. So it's different from, so this is an underscore. So a variable name should always start with either a letter or an underscore, a character or an underscore. You don't have a variable name starting from maybe, let's just say 5 output. Maybe output, I just say 5 output, for example. Or I come and say output. Okay, let's quickly do this little, let's say number 1, number 2, number 3, number 4, number 5, okay, let me put so that you know. Number 6, so we are going to read all the rules and look into this variable name from 1 to 6 and tell those that are correct and those that are not correct. These are the rules. Variables are containers that stores the name. A variable name must start with a letter or an underscore. It cannot start with a number, but it can contain number after the first character. It can be as simple as just an alphabet, though this is not a good one. It can be as simple as just an alphabet. This is what this one is saying. You can say S. You can call it S. If you like, you can call it Y. So that is not a good one, but it can be as simple as that. I hope we are getting it. So, but it's not a good one. You don't just always come and say S is equals to Y is equals to, but it's valid. This is valid, but it's not a good one. Now, variable name can only contain alphanumerical characters and underscore. It can contain alphabet, it can contain alphanumeric, and it can also contain an underscore. But when you are using alphanumeric, the first one should not be a numeric, it should be an alphabet. Of course, the second one can be a numeric one. It can be an underscore, it can be anything, but it should not start with a number. So we say variable name can only contain alphanumeric characters and underscore, A to Z, capital letter, small letter, 0 to 9, and an underscore. Variable names are case sensitive. For example, Ade is different from Ade, is different from Ade, is different from Ade, is different from this Ade, is different from this, are all different variable names. So when you are using the variable names, they are case sensitive. If you have used a small letter, you should use exactly the same thing when you want to refer to it. If you think you just wrote ADE and you want to call it or you want to refer to it and you say ADE with different maybe case sensitive, different case rather, whether it's capital and you are now using a small or you are using small where there should be capital, is never going to be correct. So we say they are case sensitive. That is, small letter is not the same thing as what? As a capital letter. So now, back to us, please, everybody. Let's quickly look into this and answer the question. From number 1 to 6, let's treat the number 1. Is it a valid variable name, the number 1?
No.
5 output. Is this a valid variable name?
No, it's not.
Why? Please.
Because it starts with a number.
Is a number, right? It what?
Started with a number.
Started with the number. So you can see if I say 5 output is equal to 3 and I try to run it, it's going to flag an error. Look at this. The error says 5, you can see it's pointing at the 5, that this 5 is wrong. Invalid decimal literal. So it's not possible you start with a number. So that is correct. It's not a valid a variable name because it starts with a number. The second one. So is it a valid variable name or not? It's like minus output.
No, it's not about it.
No, it's not valid.
Why?
Because it has a dash.
It contains what?
A dash.
Yeah. It contains a special character. You can see the statement says variable name can only contain alphanumeric character. It cannot contain a special character like underscore, like at, like amber. So you cannot come and put all these special character like star, amber, minus, plus, at, all this one. You cannot put them. $sign, all this stuff, they are all special character in the variable name. You can't put them. Once the variable name contains them, then it's not going to be a valid variable name. So if I run this one, it's still going to flash an error. You can see it's pointing at that dash minus. That is not correct. So the third one, a valid variable name?
Yes.
Yes, because it's starting with alphabet, is not containing any special character apart from underscore, and underscore is valid. So if I copy that and run it, it's not going to flash an error. You can see it runs perfectly. No error. It's not flashing any error. So nothing. So which shows that it's a valid variable name. Let's look into the next one, underscore output. Is it a valid variable name? This one, number 4.
Yes, yes. It starts with underscore.
Yeah. So which is valid, right? So if I put that and I run this, it's going to be a valid variable name. I run that. So there's no any error because it's a valid variable name, right? So now let's see. Let's quickly manipulate that. You know, the underscore started is, and we call it a valid. What about if I do it this way? Output underscore out underscore put is equal to 5. Is it a valid variable name? Is it valid? Hello?
No, it didn't start with an underscore.
Yes, it's valid.
Okay.
Yes.
So it's valid.
Yes.
Now, the underscore does not necessarily have to start it. The underscore can be anywhere, either at the beginning, in the middle, at the end, anywhere, provided it's not a special character, it's valid. So it's a valid variable name. It's not necessarily, you don't necessarily have to start with an underscore. The underscore can be in the middle, it can be anywhere. So it's a valid variable name. And number 5, output 77, out 77 put. Is it a valid variable name? Is it valid?
It is.
It's valid because there's no special character and it's not starting with a number. So it's valid. Now, what about the number 6? Is it valid?
No.
Why?
No, it's
Special
not.
character.
Is
That's
containing
$sign.
a special character.
Special
You can
character.
see this $sign. That is the only thing that is making it invalid, because of the $sign is invalid data variable name. Now, I haven't known how to write a good variable name, the do and don't. There is a rule for writing a variable name. We have a camel case that we can use. For example, if what I want to write is like the name of countries or names of countries, you know, I can say name of countries. Maybe I want to put this as a list, names of countries. You can see that? So I want to put it as a list. And I will now come and say UK, Nigeria. Okay. You can say Ghana. I can say France. This is a list, right? Of containing the list of maybe countries. Maybe we have some arguments and the question is like, mention the, or list the countries you have ever been into. And I want to claim that I've been into 5 countries. And I say, okay, I've been to UK, I've been to Nigeria, I've been to Ghana, I've been to France, I've been to Cameroon. I just want to give that as a list. Merely saying the variable name, you already know what the list want to talk about, which is a good name. Name of countries, which is a good way of naming a variable. Another thing is that it's not starting with a number, obey the rules. Now, using the camel case, if you want to use the camel case, you ensure that every statement starts with a capital letter. This is the idea. I want to say name of countries. And it's not going to be a good name if it contains a space, because it cannot contain a special character. A space is also a special character. It must not contain a space. It must not contain a special character. So now, instead of putting it like this and saying the list, the names of countries I've visited, and I just come and say is equals to this, I will now reason like, since I have a name, start with small letter, you always start the first one with small letter, then every word will now come together starting with capital letter. Name of, now I come to the next one, I say country. This is a common case that is majorly used when you want to give a variable name. You have a snake case, a snake case as well. Like when I have the list, names of the countries, please, are you with me?
Yes.
Yeah. This was what I wrote initially. Now, instead of joining them using capital letters, you can as well use underscore like this. These are the two widely used conventions while naming a variable. This one has an underscore for every beginning of every word, name of countries. Here, I join them together. I remove the space. I join them together using capital letter for every first alphabet. Names of country. These are the best practice for writing a variable name. I hope that is clear.
Yep.
Yeah.
Yes.
These are the best practice for writing a variable name. Now, if you have this as a variable name, let me run it. And then you come here again and run this. They are all valid. Now, the only thing is that if you can choose one that is convenient or the one that you love. As for me, I use the two. I use anyone that just come to me. If I like, I use the first type. If I like, I use the second type. But that is not a good practice as well. If you are running for a code, if you are to run a code for maybe an interview, and maybe you were given an assignment to do and submit, and then maybe you were given some time to finish the assignment and submit, and then you go home, you go do the assignment, and then you submit. And from what you have submitted, if they discover that at a point you were using this type of variable name, and at another point, you started using this type of variable name, it will be assumed that where you copied your code from, the first place you copied some of the part of the code from, that person was using this. And now you went to copy another code from somewhere else, and that person was using this. So you are not being consistent. So if you want to be using this, just be used to this. And if you want to be using this, just be used to this. The same thing with using string, using the double or the single quotes. If you like, you use these, and at the same time, if you like, you can use the double quote. Sometimes it can be used against you. You copy a code from somewhere, someone that was using this single code, and then you went to copy another code from somewhere, from someone that was using this double quote. There is no penalty for that, but it can be used against you, like you are not being consistent. If you want to be using single quote, use single quote. If you want to be using double quote, you use double quote. As for me, I use the two together, though it's not a good practice. What is the reason, or what is the functions of using a variable name? A variable name is used to hold a data. It's a placeholder, it's a container. For example, this variable name, names of countries, is a placeholder for these names of the country. If I want to get the name add in this name of country, I will just have to call it variable names. Let me call it and print it. Control V. If I run this, it will give me all the list. You can see these are all what was added in that list. You can easily call it. So a variable name is used to call or to print on a screen the value that has been stored in it. Sometimes you may think like, we have already seen that this is UK, this is Nigeria, this is Ghana. This is because the output, we are the one that gave the output, and we can easily see that. In some cases, if we have an output that is hidden, we may not know what the outputs are until we call the variable name. For example, if I come and say, let me define a list of number is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 5. This is a list of number. So I don't need to tell anyone what the list of number is. I don't even need to call it. You already see what the list is, or what is inside the list. And now I want to run some other code based on the list. I now say if, okay, for numbers in list, don't worry with all this I'm doing. All these are what we are going to know later, but for now, let me just, for number in this list, what should you do? If number less than let me say less than, maybe if number less than 5, okay, if the number is less than 5, let's have a new list. Let me define a new list. Before that, maybe I have new numbers, new list. For example, since I'm using the convention, new list, let me make my new list to be an empty list. Empty list. I have a new convention. If number is less than this, what should happen? If number is less than this, I want to append for number in this, we say new list I have an error. I did not put column. Then after that, I did not indent. Please never mind. We're going to get to this point. Okay. For number in list, that is in this list, if the number is less than 5, we should have another new list that contains all the numbers from this list that are less than 5. And I'm sure we know the numbers in this list that are less than 5, they are 1, 2, 3, 4. I hope you see that now. Hello? Hello, everyone?
Yes.
Yes, we're there.
I will see that.
Yes. These are the things we can do with, if I like, I don't print. If I like and I don't print it, I just come and run it. And at the end, I now come down here and say, what are the new list? For now, you don't know, but you can dry run from the statement. I said, if for numbers in the list, in this list, if the number is less than 5, the new list, the new list initially was empty. You should append those numbers in the new list, which means if it is less than 5, we should add them in the new list, which should be 1, 2, 3, 4. If I change it to greater than 5, then it means what I will be expecting from the new list should be 6, 7, 8, 9, 10, 11, 12. So if I run it and I now come down to call for the placeholder of the new list, which was empty initially, will no more be empty if I run it. So this is 6, 7, 8, 9, 10, 11, 12, because I have changed the condition to greater than 5. These are the functions of a placeholder, like a variable. So variables is just by the way. We now want to move into this where we started from. That is, we want to start talking about this data type one after the other. And the first one we are going to talk about now is integer. Because I told us that the first one we did was just a quick introduction to everything about data type. So far, so good. We have an idea of what a data type means. We have an idea of what we call a placeholder, like a variable, what a variable should look like, how to write a variable, a valid one, and the function of the variable as a placeholder, and at the same time to be able to print out a value on a screen. Those are the functions of a variable. Now we want to take them one after the other and talk about integer.
I'm going to ask a question about the append, how you use append.
How you use what?
Append.
Append, yeah. We are coming to that. That's why I just say, don't worry about all this for now. We will take every of these one after the other. Later we get to what is called condition, if conditions, and for all those conditions, and we are going to be treating them. Even before then, we will take all these data type and talk about the methods, because there are methods that can be used on various data types. So since we are taking the data types now, we understand what we mean by this append with time. Don't worry yourself about that. That is a problem when we are learning a programming language. We just want to know everything that has been done, but it's not possible. It's not possible for now. We just have to keep calm and keep going. We'll definitely get there. You'll discover that you can use append anyhow, anytime you like, okay? For now, just keep calm and let's keep watching. Then let's start from integer. So we already understand what integer means, okay? So now there are some things you can use on integer. Are you with me? Hello?
Yep. Yes, we're here.
We'll talk about methods that we can use on different data types. One of the methods that we can use on different data types, we pick the data type one after the other and talked about the methods that are unique to them, okay? So like the append you are talking about is unique, is also a unique functions, inbuilt functions that can be used on lists. So when we get to lists, we understand the append very well. So, but let's start from the list to get into the complex. So we are going to take integer data type and then talk about some of the things that can be done on integer. So we already understand that integer is a number. Let's take integer and float together. So that's okay. This is what we are going to talk about now, integer and float. So what are the methods that can be used on integer and float? Majorly, most of the things that can be done on integer and float, they are basically operations, like arithmetic operations, like we can do additions or mathematics on them. So when you have a float or an integer, let's say number one, num1 is equals to 20. And let's say num2 is equals to 15. So what are the things that can be done on this number? What are the methods? What are the things that we can do on this number? Most of the things we can do on the numbers, they are arithmetic operations. So if you have num1 and we have num2, let's look into some of these arithmetic operations that can be done. We can say sum of num. Let me use this type, sum of numbers. So it's a simple, or maybe let's just say sum of num. It's a simple arithmetic operation. Like this can be num1 plus num2. That is the first number plus the second number. So when you run it, it will run. If you want to print it, you can just say print. We have print function that you can use. What are we printing? We are printing the outcome, that is num sum. If I say this to print the num sum, of course, should just give me something like 40 something. That is 45. This is an arithmetic operation that can be done. We can do subtraction. We can say num1 minus num2 minus num2, and you get this, 15. You can say num1 times num2, you use multiplication like this, and this is what you are going to get, 450. You can say num1 raised to power num2, and when you want to say raised to power here, you use this. Raised to power. This is raised to power. So what I'm saying is num1, that is 15 raised to power 30. If I do that, it's going to be, what is this? No, num1, num2, no, this is not correct. Power, this should not be. Oh, 3 is, I think, is 2 asterisks.
Yeah.
Yes, it's 2 asterisks, okay? Num1 raised to power num2. That is 15 raised to power, okay, 30 raised to power 15. 1, 4, 3, 4, 8, 9, these. These are arithmetic operations that can be done on different numbers. You can subtract, you can add, you can do so many arithmetic operations. What are the other operations that can be done on different numbers? Let me quickly copy some and let's look into them. Please excuse me. Just want to already have them. Just want to later you get all these. Please, are you with me?
Yes, I'm here.
Okay.
Yes.
Now, let's look into all these operations that we can do on different numbers. Now, when you have an integer or a float, let's even make some of them. Let's make num2 a float, for example, because it can't just be, let's say, 0.5 or 0.3, 0.33. This is a float. Okay? So we can still add a float with, let's say, plus this is going to give us the output, 45.33 when we say num1 plus num2. When we subtract, minus, it can be num2 from num1, anyone you choose to. This becomes 14.65. Let's try num2. Num2 minus num1. It can even be num2 plus num2. So it can be anyone. So this is minus 14.65. Let's say raised to power num2 raised to power num1. You remember raised to power, that is this. Raised to power this. You can get that. That is 3.66 exponential 35. You can do all these operations on numbers. So we say in we can do arithmetic operation like addition, which we have done. We can do subtraction on that. We can do multiplications. We can do division. Of course, we want to divide. We just simply say divide by this. When you say num2 divided by num1, or let's say num2, that is 15.33 divided by, that is going to be less than 0.5. That is 0.511. Okay? So we divide, we multiply, we subtract. These are the things we can do. We can use these for addition, these for subtraction, these for multiplication, and these for division. These two, this other one, we may not understand, but let's quickly explain what's the name. The addition, subtraction, multiplication, and division, they are straightforward. Everyone understand that. But the other one, like floor division, modulus, and exponential, maybe, oh, exponential is easy. That is raised to power something, which we have done. But we have not done floor division and modulus. What do we mean by modulus arithmetics? Let's use a things that will be easier for us. Let's use num1 and num2. We have num1 and num2. Let's make this divided by, let's make this one 20 this time around. We have changed our num1 to 30 and our num2 to 20. Now, if we say 30 divided by, okay, if we say maybe division, def, let me just say def is equals to let me say division operation is equals to number 1 divided by number 1 divided by number 2. Please, what do you think we are going to get from here? It's going to be 1 point something, like 1.5, 1 point something, right? Because if we say 30 divided by 20, what are we going to get? We are going to get something like, right? So if we run it, let's print it. We are going to print it at the same time. Let's print . $1.5, right? Num1 divided by num2. We get 1.5. But when you talk about floor division, the floor division, we only take the integer part of it. We not bother talking about the decimal part of it. If you say num1 floor division num2, you are just going to get 1. Let's try that. And floor division, the difference is that you use double division. When you do that, you're just going to get something like 1. That is the floor division. If we only take the integer part and forget about the decimal part. Please, do we get that?
Yes, we do.
Yeah, that is floor division.
So can you say when you want to round up numbers?
Yes, just like that. Like you want to round up. But this is not really round up, because if you say round up, it's going to be like if it is 1.5, it should be 2, right?
Round down.
So this is not round up. It's like it's just taking the integer part alone. Even if you get 2.99, the answer is going to be 2. If you get 1.99, for example, let's change this to 17. Num2, let's change it to 17. And instead of, let's do first division. if you do this, this is going to be 1.764, which if you want to round up should be true, right? If you go and try floor division, it's not still going to give you 2. It's going to take the integer part, that is 1. All these are their application. If you want to round up, there is a module you can call for that. I think we have something like sale and some other things like that. We can use them. Now, anytime you use the modulo of the floor division, a floor division will always give you the integer part, not considering whatsoever the decimal parts of it, like 9.99, which will be 10, 9.2, which will be 9, but it's always going to give you the decimal part. Someone said round down, so we always give you the integer part alone, not considering whether it is approximately going to increase. That is floor division. All these things we are going to get used to it when we are talking about control flow. When sometimes you just have to write some code that you only need to take the integer part, you are less concerned about the decimal part. In that case, you quickly take the floor division. There is another one that you are less concerned about whatsoever division it is. You are only concerned about the remainder. For example, if you say 30 divided by 17 is going to be 1. Remainder what? What are we going to have as a remainder? We are going to have 8 as a remainder, right? Hello? Hello, everyone?
Yes.
We are going to have 8 as a remainder. So in a case where we are not particular about the number of division, we are only particular about the remainder, we use modulus, a modulus operation. For example, if I use modulus num1 module num2, I will only get 17. It's only going to give me the division, the remainder after dividing 30 by 17. What is the remainder? There are some cases where you have to run a program that's the only thing that you are interested in is what the remainder is. You only need the remainder. The remainder is very important to you that you want to know, is the remainder equals to this? Is the remainder less than this? Is the remainder is this? So if the remainder is that, do this. So in that case, you use a modulus operation. It's very, very important. So if you use a modulus operation here, the answer is definitely going to be 13. What we are saying is 30 divided by 17. When you divide it, that is 1. What is the remainder going to be? The remainder is 13. Get me the remainder. Please, do we understand that? Let's use a simple like 10. Num1, and let this one be like 4. If you say 10 divided by 4, the answer should be 2 point something. If we call floor on this, we are going to get 2. Let's call floor. Okay, before then, let's just say num1 divided by num2. We should get 2 point something. That is, oh, okay, I've not run this. This is 2.5, right? 10 divided by 4, 2.5. If you call on the floor and you run it, you are going to get 2 because it will only take the integer part and forget about the decimal part. Hello, house?
Yep.
Yeah.
Yeah.
Now, so if you are not running the floor and we want to run the modulus of saying 10 divided by 4, by the time we use the modulus 10 divided by 4, I think our answer should be 2 because it's going to be 10 divided by 4, that is 2.5, that is 8, remainder 2. So if I run it, the answer should be 2, but I don't want, let me use 3 here this time around because it's like this will be confusing us. Let's go back and run this and say number 1 divided by number 2, and this will give us 3.3333, 10 divided by 3. Now let's run the floor. The floor should just be 2, it should just be 3, because if we say it will only take the integer part when we run the floor. Now, but when we run the modulus will tell us that 10 divided by 3 is 3, that is 9, remainder 1. So that remainder is what I'm particular about. I say, what is the remainder? By the time you run it, that should be able to give us the remainder. Run, and the remainder is 1. That is the modulus. All these are a good application. For example, if we want to consider okay, thank you. Just to consider the useful aspect of this, let's look into this. Because sometimes you reason like, why do we need to take the integer part? Why do we need to take the remainder? Why did you need to take that? Let's run this, for example. Let me look for a range of number and run. Please, are we all there?
Yes, you are.
Because sometimes we just reason like, why should we do all this? What is the importance of this? Why should we need to know that we have a remainder? Why should we? So let's cite an example. Let me run an example of the range, and that will make it more clearer. I want to create a list. And that list is going to be list of number. Let me just say list of number. Of numbers. And let me do it this way. It's equals to, let me use list instead of tuple. I love working with list. Okay, what happened? Okay. Sorry, I got an error. Sorry, I'm coming.
It is not closed.
Okay, yeah, thank you. Thank you. Yeah. Okay, the list is not closed, rather. Yeah, I see. Okay. I got this list. We don't know what the lists are. What is inside the list? So if I just copy it and say I want to print it, you can print and you can just paste it. If you paste it like this, it will still give you the output. When I run it this way, I will still get the output. Or I run this way, I say print list. I run it, it still gives me the output. So these are the output. Do we understand this output? No. Don't bother yourself about this. What I did was that we're trying to find the range of number from 0 to 100 and square them. We say 0 square is 0, 1 square, 1, 2 square, 4, 3 square, 4 square, 5 square, 6 square. These are the range of numbers in this, but this is too much. Let's just make it 10. Let's make it 10 so that we understand it better. So let me run it again. Yes, the range of number from 1 to 10 is 0, from 0 to 10 rather. That is 0 square, 1 square, the square of numbers from these from 0 to 10. These are 0 square, 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, up to 9 square. It's not going to get to 10. It will always be one less than what you define. Okay? You will understand the range later, don't worry. But this is the list I just want to work with. Now, in this list that I've gotten this list, what I want to do now is I want to see if every number, I want to get every odd number in this list. Odd number. How can I get the odd number in this list? The odd number like 1, 9, 49, and 81. So I want to get it. I am only interested in the odd number. If that is what my interest is, I can use this operation to get them out. For example, if I come and say, for numbers in this my list, for numbers in this my list, if all these numbers are in the list, what should happen? If I divide everything, these numbers, each one of them, if I divide them by 2, if I divide, for example, let me just say the numbers in this list, which I call numbers, this is what I decided to call it. Okay, if I like, I can call it num. If I call it num, I say if num is num divided by num module 2. Yes. If I divide it by 2 and I get a remainder, it means it's an odd number. Because if it is an even number, I should not get a remainder. If I say number divided by 2 and is equal to 1, that is when I take a number is 0, I divide it by 2, it's not equal to 1. The remainder is not equal to 1. Or I take num1, I divide it by 2, and the remainder is not equal to 1. If I divide it by 2, the remainder is not equal to 1. Any one that the remainder is equal to 1, we call it odd number. If num modulo 2 is equal to 1, that is when I divide this number by 2, I get a remainder of 1, then it means that number is an odd number. So initially, I can set my odd number to be empty. Let me say odd number, odd num is equal to an empty list. You will use append a lot. So it's equal to an empty list. And I will now want to say, okay, now this is my empty list. I want to be adding numbers from here. This number should be 1, 9, 25, 49, and 81. Those are the odd numbers. I want to get this odd number. How can I get them? If I divide every number by 2, if I get a remainder of 1, that number is an odd number. Because normally, odd numbers, hello everyone?
Yep. To follow.
Yeah, we're here.
Yeah. Normally, even numbers, when you divide an even number by 2, the remainder should be equal to 0. The remainder should not be 1. So anyone that has a remainder that is equal to 1, what should I do to it? I will append them to odd number. I just say odd number dot append. Append what? It should append the number. No. So this num are inside this list. That is all this number inside this list. We have both odd number, even number, and prime number there. So I want to get out my odd number. How can I get it out? I will take each of these numbers, one after the other, and I will divide them by 2. Any one that has a remainder of 1 is an odd number. So if that is the case, I say that is my odd number and I end my program. If I end my program like that, if I end my code like that, I can print out my odd number now. I should have a list of odd number. If I call odd number now, odd, let me just say print odd numbers. Odd numbers. So if I print this odd number, I should have something like the odd number 1, 9, 25, 49, and 81. Please, did you get the point?
Yeah.
Now, we are not teaching ourselves on how to write code of for and if. We are only telling ourselves the importance of these arithmetic operations, the importance of these modulars. That is the only thing we are only talking about. We come to a point where we understand on how to write all these codes. Don't bother yourself about the code for now. You have to understand the principle so that when you get to writing the code, it becomes easier. If we just jump to getting all this thing done, and by the time I begin to set a condition, you'll be like, where did you get this condition? How are we supposed to know that this is going to be 1? How are we supposed to know what the odd numbers will be? How are we supposed to know what the even numbers will be? Then it means you must understand all these little conditions first. Condition like floor, condition like modulars, and there are other conditions that you can run on numerical data. So some of these things you can run on numerical data. Because of our time, we only look into them so that in our next class, we run over this again and then try to balance off before we move to floats, the conditions, how to check some of these conditions. There are other things you can do on numbers, apart from arithmetic operations. You can do something like condition to check if something is present and things like that. So let me quickly look into that because of our time. Hello, everyone. Are we happy to still do sometimes, or we are tired for today?
Yeah, we're happy to be here.
How's everyone doing? Everyone doing okay?
All good.
Okay.
Okay.
Okay. Yeah, okay.
We carry on, yeah?
Okay. That's
Yeah.
good with me as well.
Yeah.
So we are talking about the operations we can do on numerical data. Let's quickly recall what we are doing so far. Recall. Or what we have done so far, rather. It will not make sense now until when we do a lot and we begin to recall them one after the other. That is when it will make sense. And when we begin to apply them. It is in the applications that the teaching becomes very important, makes sense to you. We have talked about the data type. So the data type of integer, floats, etc. We have talked about variables. Then in variables, we know how to name variables. We know the do and don'ts. We know the valid variable names. Those, when you say valid variable name, you know the usefulness of the variable names, like to be able to store data as a placeholder, and at the same time to be able to print out some stuff on your screen. That is the function of a variable. And then we now begin to take this data type one after the other. We are on the numerical data type, that is the integer and the float. This is where we are. And on this, we say there are some operations that can be carried out on integer and float. Those operations are arithmetic operation. We have been able to talk about the arithmetic operation. Now, on the arithmetic operation, we say we can do addition of numbers, we can do subtraction of numbers, we can do division of numbers. division of numbers, we can do multiplication of numbers, then we can do what is called raised to power, that is exponential. We can do exponential. We can do what is known as floor division. A floor division where you only take the integer part, and at the same time, we can do modulus operation. And we have been able to apply the practical implication of modulus operation, like getting out odd number or even number from a range of numbers. That is just the application, and some of them we can use some of these applications. We are not yet interested in this coding. We are only interested in how to do all these operations. Now, the next thing we want to talk about is the assignment operation. Assignment operation simply means equals to. Equals to. When you say something is equals to something, that is assignment operation. What are the various assignment operations that we can have? So, I'm checking some code. If I'm not getting that, I'll just, okay, since I'm not getting it. An assignment operation, for example, when you say, like S is equals to 5, for example, you are assigning this 5 to S. That is all what assignment operation means. At the point when we begin to assign things to our variables, like saying variable 1 is equals to tuple or is equals to anything. Anytime you use this equals to, you are using an assignment operation. You are assigning a value to a particular variable. The value you assign can be a number, it can be a numerical type, it can be a string type, it can be a bool, it can be anything. That is an assignment operation. You only assign. Now, the other thing we can do is comparison operation. So how do we compare two things? How do we compare them? We want to know if this is this, if this is that, if this is greater than this, if this is less than this. So that is what comparison means. How do we compare? So is it? They include something like equals to, not equals to, greater than, less than, greater or equals to, less or equals to. That is assignment operation, comparison operation. We are done with assignment operation. There is no big deal in assignment operation. Everything we do, we have been doing using assignment operation. So let's quickly go into the comparison operation. How do we compare? What are we comparing? So, in comparison, we use this equals to. There is difference between this equals to and the single equals to. For example, if I say 5, if I say number 5 is equals to 8. It means this is an assignment operation. I have assigned this number 5 to 8. I have assigned 8 to number 5. Let's say number 9 or number 6, let's just say 6, is equals to 15. It means I have assigned this 15 to variable number 6. I decided to call it variable number 6. It's different from this equals to. Now, this is comparison. I want to check, for example, if number 9 is equals to number 6. For example, I say number 9, if I run this, of course, you know, number 5 will always give me 8, and number 6 will always give me 5. Now, I now want to check and say number 5 is equals to number 6. Are they equal, please? Everyone?
No.
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 Now,
No?
it means the comparison operation. Now, if you are not saying no, what are you going to say? Is it going to be no or yes? We always give us a bool as in return. If I run it, if you tell me it's false, you can say, when I say number 5 is equals to number 6, it's telling me, no, this is not equal. I hope you can see that. This is telling us is equal, is not equal. That is the difference between, it's not assigning the value of number 5 to number 6. It's checking if they are equal or not. Since 8 is not equal to 15, automatically number 1, number 5 is not equal to number 6. For example, if I want to check the height of someone, I want to say maybe we are arguing and we say, okay, the height of Mr. A is equal to the height of Mr. B. And someone has gotten the height of A and say AI somewhere elsewhere, measured it and send it and say the height is A. And someone measured another value of the one we want to compare it with and say the height is B and say 6. Or and say, okay, maybe B. And we now say, okay, let's compare. We now say number A and we now say A equals to B. If it says true, it means the same height, the heights are the same. Or if it says false, it means the heights are not the same. This is where the comparison operation comes in. It always gives you a bool, whether true or false. There are other things we can do. If we are not using equal, we can also use, these are the different things we want to consider here. We want to consider if they are equal, if they are not equal, if they are less than, if they are greater than, if they are less or equals to greater than other stuff. So let's run that on this stuff we have. And we always get bool. For example, let's run, we have run equals to, and we see that they are not equal. It is false. Let's run not equal. If I say num1 is not equals to num2, you can see how we denote not equal. Is not equals to num2. What did you think should be the answer, please? Num1 is not equals to num2. Is that correct?
That's true.
True.
Yeah,
It will be true.
so it's true. It's not equal. That is where we use comparison operator. And we say that it's very useful. Some of the if that I've been using, I've been saying if this is equal to this. If that, you can see. Oh. Are you with me?
Yep.
Yes.
Sorry, I'm trying to check it. Okay, good. So you can see, I say if percentage 2, that is modulus 2, is not equals to, you can see, I've been using it to compare something here. These are comparison. You are trying to compare that whatsoever you have here, is it equals to 1? Is either going to be yes, it's equals to 1 or it's not equals to 1. If it is not equal, it should do this. If it is equal, it should do this. So that is how we use comparison operation. We are going to use them a lot. Now we are saying there's num2 equals to, it's not equals to num6, then that is true. If it is not equal, what should happen? We can now set some other parameters. Now, is greater than, we are saying this is greater than. Num5 greater than num6. Is it greater?
False. No.
It's not greater. That is false. If we run it, that is false. Then is it less than num5? Is it less than num6? Is it less? Num5 less than num6?
Yes.
Yes. So that is going to be true. So there is this other condition, less, greater or equals to, greater or equals to 8 is greater or equals to 15? No, right? So it's going to be false. Now, if you use less, you say greater and less or equals to. Is it less or equals to? Yes, it's less. It's less than or equals to. So when you run it, this is what you get. It's true. This is how to run comparison operators. So, and we are going to be using these a lot. We are going to be using it a lot when we want to be talking about if condition, else, if else, for, and etc. We'll be using comparison operators. So I just want, this is just the overview of what the coding look like. It's not going to be interesting for now because we have not even started coding itself. We are only introducing ourselves to different data types. And when we get these different data types, we get it very well, we can begin to talk about coding, loop, control flows, and so many other things. But we have to get this initial part very well. Like sometimes if I want to teach mathematics, I don't just start teaching mathematics from, for example, I want to teach something like sets in mathematics, or I want to teach something like quadratic equation in mathematics. I don't just jump to the to all this. I start from numbers, because if you don't understand numbers, you cannot understand all this other stuff. Sometimes I want to talk about set, and a statement say a set of a number that are prime number. You don't even know what prime number is, and you think you want to do the set, and then you don't know what odd number. So I always start from the beginning, which will not be interesting, which will not be the subject of what we want to do, but it is important that we know them. This, I think, because of our time, we can stop here for today. So why in our next class, I believe we'll be able to have a better understanding, and by then every one of us will have had our Visual Studio Code set so that we can begin our coding proper. The introduction, again, we're still going to the introduction. We quickly do the quick overview of what we have done, and then we quickly rush over. We are still on number. We are still going to go to string. We are still going to go to tuple, list, dictionary. Then when we are done with all these, that is when we can easily do so many things that I believe you love to do. But for now, we don't have choice. We just have to understand the basis of all these data types. They are very, very important for us to be able to move forward in this journey. Even when we get to data science proper, we are still going to be referring to them. And some of these, the inbuilt function we'll be dealing with here, we'll still be using them when we get to the data science proper. So please, if you have any question, you can ask. If you have anything that you want us to clear before we call it a day, you can kindly let know. Please speak up.
Thank you. Thanks, Abdul. Great. Yeah, any questions, anybody, please. Now's the time to air those. We've definitely overrun, but I think it's a good thing to get an idea of the format, the principles that will be used kind of going forward. So, but yeah, any questions, please share them now with Abdul. Thank you.
Hello, everyone. You can speak.
Yeah, well, there's no question really. I just wanted to say thank you for your introduction. I think it's really, really insightful. I've done some coding, but it's been a while, so it's really helpful to jog my memory from the beginning. So yeah, thanks.
Thank you. Amazing. Anybody else? Any comments, any feedback? Please, guys. For Abdul?
So, as for me, I will love that. I even want to ask, how many of us here have our system with us? because the most important thing is when we are doing this, it will be good we code along, and we can be creative sometimes. Sometimes some things I do, you want to do another things that is different, and you get an error. So you can have that, why you get this such errors, and we talk about it together, and that is going to be a good way to code along. So I want to ask, do we all have a system with us?
Yes, I think some of us have.
Yes, I do.
Yes.
Okay.
Long as well. It's nice.
Okay. That's great. So there's just the way every time the introduction is always like this, because we have to, everything will just be coming, let's touch this part, let's touch this part. But at the end, we're still going to skip some of this stuff, and we remind ourselves as we go, because we cannot finish everything. As much as I want to cover everything, it's not possible. We touch every part, but the most important part must be touched, because this initial coding is always very crucial to be able to understand any part of programming language. And specifically, we are going to be applying this in data science. And you know, as a data scientist or data analyst, we deal with data and numerical data a lot. And some of these manipulations we'll be doing them with. So I don't want a case where we get to manipulating this data and then we now begin to ask many questions. So it's better we solve the initial problem, what I think can be a problem when we get to dealing with data proper. So please just bear with us how these initial parts will always look like. I believe by next week, we're going to get it better. By then, we have going to be with our Visual Studio Code, where everyone will be more comfortable and we will be more relaxed, because we are already introduced to some of this code. So thank you all for being here.
Thank you.
Yeah, you're welcome. We really appreciate you.
Thank you so much.
Thanks.
Thank you.
Thank you, guys. We'll be sending out the recording for today's session and a feedback form, please. We would gladly appreciate if you do respond to the feedback form so that we better prepare for the upcoming sessions. Thank you.
Have a good weekend, everyone.
Thank you. Bye.
Thank you. You too. Bye.
Bye.
Bye.